Do I have this? Yes. All right, guys. First thing is questions, and then we're going to go over what's on the test. But did anybody, perchance do any of the homework and have questions on 10, 11, 12, 14, or 15?
Can you do on 11A number 12?
11A number 12. I have that one. This one? Yeah. Okay. This is a calculator question. It says estimating population growth, the population of Alaska in millions for 3 known years is as below. And then down below it says use t equals 0 for 1960. So we would have year 0. 20 years later would be 1980, and 30 years later would be 1990. So I kind of like this question because we only have to input 3 data points. So if we go stat, edit, and it was 20, 0, 20, and 30, was that right?
Yeah.
Okay, put your cursor on the name of list 2, so up at the top of list 2. Do second delete. And then do second and the number 1. Okay, then it doesn't ask us to even do a scatter plot or anything, so I'm not going to bother. It just says to find the exponential regression, doesn't it?
Yeah.
So that's stat, right arrow, and then you got to scroll down far enough to find the one that says EXPREG. It's like 0. And then list 1 and list 2. I'm actually not even going to store it because I just want to see it on the screen. So we're going to write down, it says A times B to the X. So it's 0.229, yikes.
Whoa.
This thing hates it when I drag it across the screen for some reason. 0.2286 times 1.0293, however many places you want to go, to the X. Use the regression to predict the population in the year 2009. If we did minus 1960, we'd have what, 49 years? So we're going to put that in for X. So we're going to type 0.2286 times 1.0293 to the 49. Get bothered to use that silly online calculator. And you will get a different answer depending how you rounded. I got 0.95.
Oh, in millions.
Because it was millions. That's actually an issue on the quiz, on the test tomorrow. You need to label your answer on that question because it is got a label. It's also people, but all right. Estimate when the population of the state was twice the 1960 figure. So if the 1960 figure was 0.23, we would be looking for when it was 0.46. So you would be solving this backwards or graphing it on your calculator to solve it backwards. We're looking for an exponent. Well, you know what? Well, okay. So we would divide. I got 2.012 equals 1.0293. Then I got to take the log of both sides and divide. I don't know, I rounded randomly along the way, but I got about 24 years. Anybody else? If we add that to 1960, we'd get sometime during 1984. Did anybody else get that? Does it kind of make sense? 1984 would fall in here, and 0.46 would fall in there somewhere, right? Seems reasonable. Anybody else? Questions on 10, 11, 12, 14, 15? Nothing else? I am going to talk about 16 then. Kind of. The only problems I'm going to talk about are these 5 equations. Because this test does not have questions like, what is the log base 2 of 8? Okay. This test had, that was all on the quiz, okay? This test has equation solving with logarithms or exponential equations. It has applications. It has Newton's law of cooling. It has inverses. Just factoring with logs, okay? So we're going to practice some of that. What would you do on 39? Okay. So we can leave the 3 to the x plus 3, but over here we can make 27, whoops, just kidding, we can make 27 3 to the third to the x minus 2. And then this, because they're both base 3, this exponent has to equal this exponent. So x plus 3 has to equal 3 times x minus 2. I'm just going to leave it there. We good? Excuse me. Thank you. All right. Similar question here. This is, both of these could be rewritten as what? 5. So this one is 5 squared to the 3x plus 2 equals 5 to the third. So we would be multiplying there and setting it equal to 3. So 2 times 3x plus 2 equals 3. Be okay there? All right. This is the one I'm worried about. It is on the test. And I will do another one in a minute on the other worksheet or the other slides I have. But we can factor this with what we called a U substitution. I don't know why they use the letter U, but they do. You can use any letter you want. But basically you're saying this thing squared minus 8 of those things plus 15 equals 0. Some of you can factor e to the x and e to the x. It's fine. But some of you don't see that and it doesn't make any sense. So if you do this, then you're like, oh, easy, I can factor that. U minus 5, U minus 3. Everybody okay? But what is u again? E to the x. So if we solve this, we're still not done. We have to do e to the x equals 5 and e to the x equals 3. And how do we solve that? Okay, so we're going to have ln of e, we're going to bring the x up in front, equals natural log of 5. And here, same thing, x ln of e equals ln of 3. Or you can just think about it as rewriting. Yeah. I'm just taking the log of both sides. Okay. So I have x equals ln of 5 or ln of 3. The question that is factoring on the test says give exact solution and an answer rounded to 2 decimal places. Those are the exact solutions right there. Okay. Rounded to 2 decimals would just be to type them in your calculator. But everybody okay that those are the exact solutions right there? All right. Any questions on that one? We're going to do another one like that in a second on another slide. But what are we going to do with 43? This is a super easy question. Condense, which means we multiply log base 2 of x times 3 or 3x equals log base 2 of 18, then what? Yeah, these are the same base, so they have, or the same log, so we can get rid of them and just say 3x equals 18, x equals 6. All right, not the same as number 44 though. What's happening on 44? Still gotta condense over here. But can we just get rid of that log? Well, we can if we rewrite it as how? 6 squared equals this, and some of you like to write it. Okay, what's happening? Some of you write it as exponentiate. Come on. So this takes care of, and you have x times x minus 5 equals 6 squared or 36. Everybody all right? X squared minus 5x minus 36 would factor how? Yeah, it was 6 squared, so it's 36. You're okay. So we got 9 or negative 4. Are those both going to work? We started out with a log of, and you can't take the log of a negative number, so this guy's gone. So the answer is just 9. All right. Did anybody else work on any of the book assignment and have a question? Okay. Then I'm going to talk about worksheet 17, and I'm going to add some things that are actual test kind of questions to what's actually on worksheet 17, so you can either write them down or take a picture or whatever you want to do, okay? But worksheet 17 was written because these are test kind of questions, but I've added a few. The first one says find the inverse. How do you find the inverse of y equals 5 times the log of x? Okay, switch the x and y, and then what? How do you get the y by itself? You have to divide by 5 first. X divided by 5 equals ln of y, and then you can either do an e on both sides or just rewrite it as e to the x over 5 equals y, and you're done. What would b look like if we switched the x and the y? And then what are we going to have to do to get the y by itself? right? ln of e is just 1, so we're going to divide both sides by 4, and that's our answer. All right, this is a little bit more like the one that's on the test. Okay. Can you see it? Move it up just a little bit. It is this question over here. Y equals log base 4 of x minus p. It says using the properties of logarithms, rearrange this equation to isolate the x. No, it's not. It says y equals log base 4 of x minus p. So the original equation, it doesn't ask for an inverse. It just says isolate the x. This is not on the worksheet, but there's one just like this on the test. Ideas?
4 to the y equals, just rewrite it.
Okay, so 4 to the y equals, that's what it means, right? What a logarithm means, this to this power equals this. So 4 to the y equals x minus p. All we got to do to get the x is add p over to that side, right? 4 to the y plus p equals x. Yep. Don't make it super complicated. I know it looks complicated because it has too many variables, but everybody all right? No questions? Can do that? All right. This is really a review question that was on the last quiz, but it's apparently on tomorrow's test as well. This was freaking some people out earlier today. Compounded annually would mean how many times a year? Once. So if you wanted to use compound interest, it would look like this. But isn't that really just the same as exponential growth then? Because r divided by 1 is r, 1 times. So I just said $4,500, 1 plus some rate. How long?
5 years.
Became 5,200. What do we do first? And then?
Then you do it to the third.
Whatever this is, we're going to do to the 1/5 power. Okay, so this is 1.029. We subtract 1, we get 0.029, and you could leave it like that, or you could move it over twice and tell me that that was 2.9%. We good? Seen that kind, done that kind, we're all over that. All right, Newton's law of cooling. Do we need to practice this one more time? Okay, the formula is right next to the question. I know it's also on your pink sheet, but it's just right next to the question, okay? This is not any kind of a trick. A pie is removed from an oven at 350. This is the original temperature. Put that in for T sub O. It cools to 115 degrees. That is our final temperature for now. After 20 minutes, that is our time, little t. In a 70-degree room, that is the temperature of the medium or the temperature of the surroundings if you're using your pink sheet. I think it says T sub S, but it's right next to the formula. Yep. Okay. How long does it take to cool to 98? Remember, we don't use that information yet. We're going to wait and use that in a minute after we find the constant. Okay. So, final temperature was 115. The room was 70. Original temperature was 350. The room was 70. E to the negative K, we don't know, but T is 20, so I'm going to write 20K. Yep, negative 20K. All right, do some arithmetic. And do some algebra. And then what? I got negative 1.8281 something over here equals negative 20K. .0914, anybody get that for K? All right. Then we get to start over for fun, right? This time we don't use the 115 as our final temperature. This time we're going to use 98 for our T sub F. And we're not going to use 20 minutes. We're trying to find T, where this is our K value. Sounds right. I remember from earlier today. $25.2 roughly. So if the cake, the pie, had come out of the oven and we were busy doing our calculation to find K at 20 minutes, pretty much by the time we finished calculating K, it would have been another 5 minutes and we'd be down to 98 degrees, right?
Yep.
Ready to eat the pie.
I'm so ready to get a pie.
98 seems a little warm, but as long as we're putting ice cream on, it'll be good, right?
I think by 98 it's like almost.
Yeah.
Body temperature.
All right, this is number of fruit flies doubles every 8 hours. We're going to do this formula. Whoops. Remember that's on your pink sheet? You wrote it on your pink sheet, right? Because it's doing something at a time period other than one. So it's doubling every 8 hours, so you're going to use T over 8. If it has a half-life of, then you use T over 1600 or whatever the half-life is. I think I had you write a couple notes on the sheet, maybe, about what that looked like. Here was the slide, and it said, like, the rate and the length of the half-life, etc., okay? So it says half-life doubling, etc. Does that help? So you know to use it then? You can actually do this problem with a K as well, but. All right, going back to this question. We're going to put in a single fruit fly. One nasty little fruit fly is doubling, so our rate is 2 every 8 hours. So we're going to go T over 8. How long until we have 1,000 fruit flies? So if we divide by 1, nothing happens, right? Then what? Some kind of log. Now the log of 1,000 is actually, anybody know? How many zeros? 3. It would be 3. I'm going to leave this log of 1,000 because someone's going to go home and write this down and then they're going to go, where did she get 3? So it's just because this comes out nice. If you did ln on both sides, it wouldn't come out nice, right? But in the end, you get the same answer. All right, this comes out front. So we have T over 8 times log of 2 equals log of 1,000 or 3. Then we're going to divide. Yeah, and in the end, we'll need to multiply by 8. Anybody else get 79.7? Okay. Now, I want to tell you something because it's going to apply to the next question. Can we check this real quick? If we did 1 times 2 to the 79.7 over 8,
I'm thinking 1,000 flies is a lot.
we didn't get to 1,000 flies though, right?
Right. Probably, I don't know, when you look at 79.7.
We cut off part of the decimal. We should have rounded it up. It's okay for this question. I would accept this 79.7, okay? But I want to show you on the next question. This is more like what's on the test. And I apologize, it's kind of a long question, but it's because it's what's on the post-test or the semester exam looks like this. So I want to go over this. You don't have this paper, so if you want to just talk me through this and then take a picture or you want to write it down, it's up to you. All right? It's the same kind of question. Don't get all freaked out. It says a single cell virus reproduces every 3 hours, and by reproduces it says it doubles. So a single cell. 50 such cells are introduced in a host. Calculate the amount of time to the nearest tenth of an hour needed for the population to grow over 25,000. Then after rounding, find the actual number of cells that are present. Okay, we'll worry about that in a minute. So how many did we introduce? 50, and they are, the rate is doubling, but only every 3 hours. And we want to hit, okay, does that part seem pretty easy? Okay, now do some math. I don't know, just for the heck of it. 2,500 divided by, or 25,000 divided by 50 is 500 maybe? Did I get that right? Okay, take the log of both sides, whatever kind of log you want. Or the leg, looks like I wrote leg. Okay, divide. T over 3 is 8.965 garbage, so times 3. Okay. This rounds up to 26.9, and I think because it rounded up, we're going to be fine. Okay? We didn't cut off anything, we rounded up. So the question on the test, it says it actually says nearest tenth of an hour, okay? But you need to double check that you get over 25,000. So if we put in the original equation, 26.9 over 3, here, do we get 25,000? 50 times 2 to the 26.9 divided by 3. I got 25015. Okay? So the question says, after rounding to the nearest tenth, calculate how many cells over 25,000 are actually present. So how many are there that are extra? 15. Okay? So it's a weird little second question that it asks. Anybody want to take a picture of that or anything? Everybody's all right? All right. I have one more like that. Do you want to do it or not?
Sure.
Or at least set it up? It says a certain bacteria is dying. It is halved every 6 hours. If 20,000 bacteria are placed in a petri dish, how long till they're under 800? So what are we going to write? Good job, guys. Okay. So if we divide and take the log of both sides, can I do that all at once? Yeah, I could if I could write. So the log of 800 divided by 20,000, then divided by the log of 1/2. I got 4.6 something. Did anybody else get that before they multiplied by 6? 27.86, which rounds up, right? So I think we'll be okay, and I think I made sure the one on the test isn't confusing, but it would round up to 27.9 hours. Was it hours? Yes. So if we put it back in, whoa, no, just kidding. So if we type that in, yeah, round 796.6, or I don't even care, 797. So how many under 8,000 are present? Or under 800, sorry. What did I just do? Go back a slide? So this was 3 extra bacteria, or 3, we were under by 3, because it says how many under 800 are actually present. We good? All right. Solving equations again. This one you have, this one you don't. Talk me through this. Then I have one more question. No, I have a bunch more questions. We're doing okay, I guess. Subtract 8. And then divide by 5. And then do what? E to the 6/5. So there's the exact answer, right? And then if we wanted the decimal, we'd type e to the 6/5. Approximately 3.32. That's the worst approximately symbol ever. All right. What about this one? You don't have this one, okay? You don't have this on your test, but this is the U substitution thing again. I promised you one more practice. So this would say u squared plus 3u minus 28. Factors how? So we get u equals -7 or 4, but u is actually what? Yep, we got to take the natural log of both sides, so we get ln of -7 or ln of 4. Can we do the ln of -7? Okay, so the exact answer is the natural log of 4. The decimal answer is 1.39. Everybody okay? I went through that really quick, but you got another one you can look at tonight. All right. How would we do this one? Are there any monthly payments involved here? Is it annuity? Is it a retirement account? Is it a car, a house payment? No payments at all, right? So it's just a compound interest question. $1,000, how long did it stay there though? Quarterly is divided by 4, and then it's to the power of 4 times the years. Everybody see where she got 7 years? Put it in there when he was 10, got it out when he was 17, or wants to know how much he'd have when he's 17. 16, 15, anybody have it? Okay, everybody good?
Gosh, I wish my parents did that for me. How much money I would have.
$1,600 apparently.
Exactly.
All right, Ms. H is going to put $350 each month into a retirement account. Now, what are we using? Okay, we're using our app. N is the total number of payments into the account. So 15 years of monthly payments. Everybody okay? I is 5, no moving the decimal. Present value is nothing. Payment is $350. Future value is what we're trying to find. And 12 and 12.
I didn't get that. I got 90.
Yeah, I think it's like 93.
She might have done second song. Yeah, 93,000.
93,000, how much?
551. Whoa. When you hit second entry. Oh, never mind. That was.
Yeah. You want to do alpha enter. Everybody okay?
I just got it.
All right, we got 2 more questions to do. We can do this. This one is important. Most of you will get what is the house payment, okay? But you also have to tell me what the total paid for the home is. And for some reason, students get so confused. Okay. How many payments are they making? 25 times 12. I is 4.25. What is present value? They have presently agreed to borrow $170,000 and make payments of, we don't know yet, but at the end of those zillion payments, they want to be down to 0. So their payment comes out
Whoa.
9. That's not a very large house payment for most people. 920, how much? Okay.
Oh, I put too many zeros. I'm like, why
Now.
did I get 60,000?
Yeah, that would be a large payment. All right. How do we find what total they paid for their house? They made this payment every month for 25 years. $276. Did you keep the whole decimal in, maybe?
I put the 0.95.
Hmm.
I got 276.285.
Did you put it?
Lot more money than 175.
Yeah. Okay. All right. So for a $170,000 house, they paid out extra $106,000 in interest.
These equations are so useful.
Okay.
I don't think I've ever learned things so useful in math class before.
All right, guys. Last one. This is a logistic function. Do you remember that?
Yes.
It is some kind of a population. In this case, it's little frogs have been introduced into a pond, okay? So I would suggest graphing this because it will help us find everything quickly. So I put in 120 divided by 1 plus 14e to the negative 0.6x. All I needed was an extra parenthesis around the denominator. Now, I'm going to go out like 50 years. I have no idea how long these frogs are going to take to multiply. And what is this going to max out at, guys?
120.
Yeah, we look at that top number. The carrying capacity is 120. So I think I put my window to like 150. But it's going to look like this. Okay? Then the first question says, what is the initial population of frogs? What do I do? Trace x equals 0, and it is? Well, that's not what I have. Trace 0? I thought it was like 8 frogs. Do you have it typed in funny? The answer on the bottom says 24 frogs? I think the answer on the bottom is wrong unless you guys figure out what I did wrong. Yeah, same thing. Yeah, it should be 8 frogs. The only thing is, maybe I forgot the point or something. Guys, the second part of the question, though, says, when will there be 100 frogs? That's when I put in a y equals 100. And then I find the intersection of those two equations, unless you want to have to work all that backwards.
Do you have an extra copy of worksheet?
In that bin. So this would be in about 7.1 years. And the last question was 120 frogs, right? All right, test tomorrow.